Hi everyone, this is your number 7 notes for April 13th, Monday, and this will be the only part that you need to do today for your assignment. I'm hoping that I can keep this video under 20 minutes, and hopefully this will help you figure out how to solve for Tuesday's assignment, which is on April 14th. Okay, here we go. So we have a problem here where we have two parts of the mat, which means that in between these two expressions, there's an equal sign, making these two an equation that is given to us, the original equation. So it says number 1, use distributive property. Where we use distributive property is where we have parentheses with an operation inside, meaning like a plus sign or a minus sign inside the parentheses. Now, I know you see this one, and you might think that's the parentheses with the negative minus sign, but that's only showing that it's negative 3x and it's separating it from the plus sign. So this is not considered to be used for distributive property. I'm going to go ahead and erase that. And neither is this negative 6 and neither is this negative 3. Those do not have operations inside the parentheses. Which one does have parentheses with an operation inside is this one, where it says 2x plus 1. So when we have an operation inside, it's setting up a group of variables and single one unit tiles in the middle. So which means that this is actually saying I have two groups of 2x tiles and 1 unit tile. So let's go ahead and use the algebra tiles for us to solve this, so that way you can visualize with me on what mat A and mat B looks like as we go through these steps. I'm going to warn you, number 71 is going to be very slow, but the rest of the notes will go a little faster, okay? Here we go, and I built it for us already, okay? So hopefully this will be able to help us save some time. That two groups of 2x plus 1 that I referred to before right there is right here. That is one single group of 2x plus 1. That's what was inside the parentheses. And I made two groups of it. So I end up with 4 x's and 2 1's. And when we use distributive property, that's all we're doing. We're literally just writing down what we have after we make those groups. So this is a hidden version of what we have right here. Okay. So what I'm going to write is 4x plus 2 instead of two groups of 2x plus 1. So that is represented right there. Okay, I'm going to go ahead and continue copying down the rest so that way you guys can see. Now, we didn't do anything with the right side because there was no distributive property to be simplified with. So, and when it says use distributive property for steps taken, that's all we needed to do. That was the only part that actually needed distributive property to be used. Okay, now looking at the next line, it looks like they have simplified what we already had in the second line down to the third line. So let's see if we could do that with our screen, with our tiles. Here we go. Hopefully I'll be able to still toggle. Okay, there we go. I have the 2x that can go with 2 of those 3, and then I can probably move that and make those into my 6x. Oh, sorry, not 6x, 3x and 3 negative x, making them into 0 hairs. I pulled it off. So I'm going to go ahead and do that with this part right here. I'll change the color, the 2x, negative 3x, and one of those. I'm combining like terms, and I end up with 3x. So I just mentioned it. When we make zeros and combine those x's together and combine those ones together, what we end up having is combining like terms step. Okay, so I'm going to go ahead and combine like terms here as well with the ones. And here we go. We can remove those zeros, and I'm left with 3x and 4 negative ones. So it looks like the next step is going to be called combining like terms. Okay. Combining like terms also involves zeros, making zeros, and then combining what's left over with however many we have from the different groups of terms that we used. Okay, so let's do that again on the right side. I don't have any x's that actually can make zeros, so I'm just going to put those 5x together. There it is. On yours, it says 5x. And then the 8 ones, it looks like we can make 0 pairs right here. Okay, it's not letting me toggle anymore. So I'll go ahead and pull those off one by one. And then we are left with 5x and 8 ones, which is exactly what we have on mat B on your paper, on your notes, okay? And let me erase this. Okay, it says to subtract 3x from both sides. So let's go ahead and do that on our screen. 1, 2, 3x is taken away. 1, 2, and 3x is taken away. I'll put it on this side. Okay, now we're left with 4 negative 1, so I'm going to write that in. 4 negative 1s, so negative 4. And then on the right side, equals to 2x plus 8. So I did exactly what it said, subtract 3x from both sides. If you want to show that step, it would look like this. Supposed to take away 3x from both sides. 4, so this became 0, and then 4 negatives, and then these two became 2x, and then 8. Now the next step is unknown to us, so we have to figure it out ourselves, but it looks like the 4 got bigger, or smaller, into negative 12, and then the 8 disappeared from here. So in order for 8 to disappear, that means that we may have made a 0 on that side. So if we make a 0, we need to bring in same amount of 8s, but in opposites. So we need to bring in 8 negatives on the right side. If I bring in 8 negatives on the right side, I bring in 8 negatives on the left side, which gives me if I bring in 8 negatives on the right side, I can make 0 pairs with this group of 1s, right? And these group of 1s, negative 1s, they make a 0. So if I bring in 8 negatives on the right side, I have to bring in 8 negatives on the left side of 3 groups of 4, okay, negative 1s, which is negative 12. So that's exactly what we're going to do. I'm bringing in negative 8 on both sides. So I'm going to say add opposites.
Add negative 8 to both sides to make positive 8 become 0.
Okay. So that's the inverse operation that we did. Opposite of adding is subtracting, which is same thing as subtracting 8 on both sides. So you can write add negative 8 to both sides to make 8 become 0, or you can say subtract
8 on both sides.
Either one of those explanations for the steps taken will make sense to anyone who reads your work, okay? Now we have 12 1s and then 2 x's left over on the mat A and B, okay? That I need to break these x's into 2 equal groups. If I break those into 2 equal groups, I need to break these into 2 equal groups. So if I give them equal amounts for each of those x representation, I would end up with 6 negative 1s for each of those x's. So this is what ends up happening. If I divide, like it said, divide both sides by 2, divide both sides by 2, then I end up with negative 6 on the left and x on the right. So the solution is x equals negative 6. Okay, so that's how you would show the work normally in recording work, CPM style. But Aiden, just like all of you right now, was frustrated that he needs to write so much when solving an equation. He decided to come up with a shortcut for recording his work to solve a new equation. As you look at Aiden's recording at the right of how he solved 2x plus 4 equals negative 12 below, visualize an equation mat with algebra tiles. Okay, so I'm not going to make the algebra tiles. I'm just going to have you guys kind of think it through and then answer the questions for each step below. Okay, what does the legal move negative 4 twice represent? So when I bring in negative 4 on the left side and on the right side, what is it doing? So that's what it's asking. If I bring in negative 4 here on the left, I'm going to put in my wall again so that way you can see left side and the right side of the mat. What we're doing is we're making a 0 pair with positive 4. So what legal move does writing negative 4 twice represent? Bringing in.
I'm going to keep it short. Bringing in. Same amount on both sides.
And the reason that we brought in the same amount on both sides is because what we do to one side, we got to do to the other. What legal move does circling positive 4 and negative 4 represent? They're talking about this part right here, where it has that big egg-like 0 right there. Okay, that part is saying we are making 0.
It represents making 0 pairs with positive 4 and negative 4.
Okay, what does the box around 2 over 2 represent? We're talking about this part right here. And that part represents dividing 2x into 2 equal groups. Dividing
2x into 2 equal groups.
Okay, why did Aiden divide both sides by 2? What we do to one side, we got to do to the other. So we got to do the same thing here as we did on the left side. So why did Aiden divide both sides by 2?
We have to do the same thing on both sides.
This is where I really miss being in a classroom with you, because this is the part where I would want you to try to figure things out on your own, because things would actually sit in your brain a lot better knowing that you have actually thought this through and figured it out yourself. But in this case, since we're doing videos, I'm just gonna talk over your thinking and hopefully you're able to follow my thinking as well. But for whatever reason you don't understand it, you need to contact either Miss Fu or myself and we can talk about it, okay? It says to check Aiden's solution in the original equation. I'm going to put a star here because you guys really need to know how to do this. In order for us to check a solution, we're going to take this value that we got at the end and then plug it into where x would be in the original equation, so we can see if it really makes it true. That's what a solution is. What value of x will make this equation true? So in order for us to check Aiden's solution, we're going to use the original equation of 2x plus 4 equals negative 12, but replace this x with the 8, negative 8 that we got in our solution, okay? So when we replace it, this does not mean 2 minus 8. That's not what it means. It means 2 times negative 8. So please don't make that mistake. It means to multiply, not subtract or add or write 28. That's not what it means, okay? And then I'm going to copy down the rest and solve it out. So 2 times negative 8 is negative 16 plus 4 equals negative 12. And then if we actually do that, negative 16 ones and then 4 positives, I can make 4 0 pairs with those tiles, leaving me with 12 negative tiles on the left and 12 negative tiles still on the right, which tells me this is the correct solution because it made the equation true by plugging in negative 8 for x. Does that make sense? So hopefully that makes sense to all of you. You are going to be expected to check your solution with your work tomorrow's assignment. So make sure you understand how to do that. Rewind it and watch it again if you need to. 673. The method of recording the steps in the solution of an equation is useful if you understand what operations are being used and how they relate to legal moves on your equation map. So I have x plus negative 4 plus 6x equals 3x minus 1 plus 5. So I'm going to go ahead and put another wall again to show that I have a left side to the mat and then a right side to the mat. And then A, it says, for each step in the solution, add the missing work below each line that shows what legal moves were used. You may want to build the equation on an equation mat. Okay, so let me take a breath. Here we go. X plus negative 4 plus 6x. It looks like I have 1 and 2 terms that are alike. So I'm going to combine those two. And I end up with, when I combine those, 7x. Okay, I'm going to do it again on the right side. Let's do it with that yellow. I have negative 1 and positive 5. And when I combine those two, I get positive 4 because I can make one set of zeros with that. Okay. And then the next step looks like we are going from 7x to negative 4 plus 7x to just 7x. So it looks like they got rid of negative 4. I'm going to make that into a giant 0. Let me see if I can move that over so you can still see the plus sign. Okay, I'm going to make that into a 0 pair by bringing in, hopefully you said it, plus 4 on both sides. Okay, now you see that it only makes a 0 pair on the left side but not on the right side, and that's how it should work. Most of the time that when you bring in opposite to make one side become a 0 pair, it's only going to work for one side. It shouldn't work on both sides. So if it works on both sides, then you did something wrong most of the time, okay? So here we go, 7x, we brought it down, we have 3x, and then we have 8. That works. So that was the next step. Then the next step after 7x equals 3x plus 8, it looks like they removed 3x from both sides because they were identical pairs, okay? So that became a 0. They went bye-bye. And then I have 8 on the right, and then I have 4x on the left. And then the next step, hopefully you're saying it right now, we're going to be dividing both sides by 4. If that was a negative 4x, you need to be dividing by negative 4 on both sides. But since that's a positive 4, we're going to divide by positive 4 on both sides, leaving me with x equals 2. So now we're going to check that the solution is correct by using the original equation. So here we go. Let me write out the original equation. X
plus negative 4 plus 6x equals 3x minus 1 plus 5.
Okay, and then every time I see an x, I'm going to replace it with a 2. So this is going to be 2. This is going to be times 2. And that's going to be times 2 as well. And then I'm going to copy down the rest.
So that's 6 times 2. And then on the right side, it's going to be 3 times 2 minus 1 plus 5.
So let's do order of operations. We're going to do the multiplying first. 6 times 2 is 12. 3 times 2 is 6. 6 minus 1 plus 5. I'm going to copy down the rest here as well. 2 plus negative 4. Since we took care of the 6 with multiplying with 2, I don't need to rewrite it.
I'm going to go ahead and shrink this down so we can write some more. Maybe I can place it there for you guys, and you guys can see it.
And then we're going to go left to right for the next step. 2 plus negative 4 is negative 2 plus 12. 6 minus 1 is 5 plus 5. And then when I do negative 2 plus 12, I have positive 10. And 5 plus 5 is positive 10. So it works. So is the solution correct? Yes, it is correct. So x does equal to 2. X equals to 2. Okay? And then these two parts right here, A and B, with checking your solution, I would like you to do it on your own and then check back on this video and see if you got those right. I'm going to do like a time-lapse version for 74. So go ahead and come back after you work it out. Pause the video right now, and then I'm going to fly through it so you can check your work. Okay? Thanks.
674a, here we go. Put up a wall. And then combine my terms, negative 2x with 2x becomes 0, so 0 pairs. And 5 and negative 5 becomes 0, so there it is, 0 equals. And then these two become negative 2 plus 6x plus 2. And then I end up with this negative 2 and positive 2, combine my terms, and I end up with 0. They go away, and I'm left with 6x equals to 0. If I have 0 tiles, but I need to make 6 groups, I can still make those groups by dividing into 6 equal groups, and x would equal to 0. To check your solution, you would go to negative 2 times 0 plus 5 plus 2 times 0 minus 5 equals negative 1 plus negative 1 plus 6 times 0 plus 2. And we all know when we have this side completely simplified, it should still be 0. Okay, so let me go ahead and do that. Next line, different color, 0 plus 5 plus 0 minus 5. And I have another set of 0. On the right side, we have negative 2 plus 0 plus 2. Negative 2 plus 2 is 0, so 0 plus 0 is 0. So it works. So 0 equals x equals 0 is our solution for part A. Part B, 3 groups of 4 plus x equals to x plus 6. I'm going to go ahead and put up a wall and then make these 3 groups of 4 become 12. If I have 3 groups of 4 ones, I have 12 ones. 3 groups of x is 3x equals to x plus 6. Okay, then I'm going to isolate the 3x on the left side. I want to keep this by itself. I'm going to eventually move the x on the right side to the left side, but I want to move this one first. So I'm going to go ahead and subtract 12 on both sides to make this 12 become a 0. Then I have 3x left over on the left side, and I have x, and I can make 6 zeros here. I shouldn't put a 0 there, so I have 6 negative 1s left over. And then I'm going to bring in 1 negative x on the right side, which means I have to bring in the same amount on the left side, and I end up with 2x equals to no more x's, but I have 6 negative 1s on the right. Then I'm going to divide both sides by 2, because I have two x's to equally divide the negative 6 one tiles and end up with negative 3. To check your solution, we plug in our solution into our original equation, which was 3 groups of 4 plus negative 3 for the x equals negative 3 plus 6. Okay, so if I have 3 groups of 4 and 3 groups of negative 3, I'm going to end up with 12 ones and 9 negatives. And I have 3 negatives on the right and 6 positives on the right. I can make 9 zero pairs here on the left, leaving me with 3 positive ones. And I can make 3 zero pairs, leaving me with 3 positive ones. So that works. So this is the correct answer.